Welcome aboard to our webinar, Applying AI to OpenStack Monitoring. My name is Dror Mann. I'm leading the product development at Loom. And we have an exciting agenda today. So just one thing about the format. Anyone who has a question, just shoot us a note in the Q&A section within the Zoom app, and we will address this at the end of the webinar. All right. So you see my screen now. Just a few words about my background. Prior to Loom, I was the head of product at Voyager Labs, where we built social network analysis platform. The purpose was to extract insights out of social media, and we did a lot with graph databases, variety of big data technologies, and basically all sorts of fun stuff. And back in the days, I was the head of operations and basically a data nerd. Like all of us in Loom, we came from a background of intelligence, and we've been developing technologies that allowed us to distill insights from big data, especially in places where there's limited manpower. This was and still is actually our goal, where we focus on harnessing technology for the sake of intelligence rather than for information. So today we're going to look on the world through these intelligent glasses, and it's going to be great. But before diving in, we have some exciting news to share with you all, as well as some exciting guests. Loom currently is nominated as the AI Leader of Year 2017 by Information Age, which is awesome, and they will be announcing the winner tomorrow, so keep your fingers crossed for us. And with no further ado, I'd like to welcome our special guest for today. I'm sure anyone who works with OpenStack environment doesn't need that kind of an introduction to Ben, but still needs to keep things informal. So I'd like to introduce Ben Silverman of Onyx Enterprise Solutions to our event. Ben is considered one of America's top OpenStack authors and cloud architects. He's been involved with cloud technologies for many years now and presented at the OpenStack Summit for the last 4. Ben started his cloud journey at American Express by creating one of the largest financial services OpenStack Cloud in 2013, and then went to work for Mirantis, where he successfully built clouds for many Fortune 500 customers. His latest book, OpenStack for Architects, published in February by Path Publishing, has quickly become a top seller. So Ben is a long-time active technical contributor to the OpenStack Foundation and just recently finished editing and updating the OpenStack Architecture Guide documentation for the latest release. So welcome aboard, Ben, and thank you so much for being here with us.
Thank you, Dror. I appreciate the invite, and I look forward to participating in this webinar.
Great. Likewise. All right, so let's get to it. Let's talk about the agenda for today. We're going to talk about the digital era and the new DevOps challenges. Then we'll dive into OpenStack monitoring challenges. We'll move forward, discuss several applications of AI in the industry, and we'll tie it all together by showing you how can you harness AI today in your daily OpenStack monitoring activities. Lastly, we're going to have a live demo to see AI in action, and I'm going to leave enough time for Q&A for Ben and myself, and also some polls along the way. So stay tuned, and let's get to it. Okay, so let's talk about the reality today. As you'll know, in today's digital era, most businesses are digital or in a digital transformation, which means that the physical business has been replaced by systems, and that means more work for us as a DevOps, TechOps people. Now, in fact, the ops engineers have become the people that's responsible for the digital experience of our customers. And when your company systems are misbehaving, your customer satisfaction is affected, which leads to churn. It's that simple. Now, people look on applications or websites and think how simple are they, but we all know that the things that look very nice and simple are the hardest to do. And in reality, there's so much complexity and technologies under the hood that makes these things look simple. And in the new reality, so developers are becoming more faster and more agile, but the burden has been shifted to operations, that us. This means that managing and monitoring is the new weakest link, and it's very hard to prevent failures. So most of us just focus on detecting and resolving as fast as possible. But if this is not enough, let's add some more complexity to it and talk about cloudification and microservices. So with cloud computing on the one hand and microservices architectures on the other, it becomes even more complex, mainly for three reasons. First, cloud computing means abstraction, and you're now struggling to understand what's the impact of a performance issue of, let's say, a host on a different components of your application. And B, these environments dynamically change, and of course, it's so harder to stay on top of everything. And three, microservices equal disparate data sources. Each emits its own logs and metrics, so that tracing and correlation becomes an inherent part of root cause analysis. With that, I'd like to ask you, Ben. You've been working with many firms in different stages of cloud maturity. What, in your view, are the major challenges that these companies face?
Thank you, Jor. In this chart, in this slide, we see a bunch of different stacks, and it's funny because it really mirrors my career. Starting in bare metal and now working in serverless. We can look at this chart as a maturity model or as a chart that shows the level of complexity when it comes to cloud or new agile models. On the very left, we have a stack that was very easy to monitor, very easy to troubleshoot because all of the components were discrete. And on the far right, we have a model that is built on several layers of complexity, and some, and in many cases, most of the serverless parts are abstracted from the operator and from the users. Right now, what we're talking about is IaaS, which still allows consumers to monitor and have visibility into the infrastructure orchestration engine, and allows you to troubleshoot problems that you see. When you move from the infrastructure as a service model to the serverless model, if you do not have your monitoring, troubleshooting, and processes down at the infrastructure as a service layer, the following layers or the following stacks add layers of abstraction, as you said. And if you're not solid in your infrastructure model, as I've seen in the customers, what happens is all the additional layers of abstraction tend to hide problems that currently exist that were never found in the infrastructure model. So as the layers of abstraction and complexity increase, it makes troubleshooting exponentially harder, exponentially more difficult to find root cause analysis because of all the different additional layers of abstraction. Companies get very frustrated, and they end up adding exponentially more operational folks with higher level skills to try and troubleshoot all of these layers. And they start from the highest level of complexity and work down, which is really the opposite way we should look at this. And it is from the infrastructure layer up. So this is a good chart that shows the maturity level, but it also shows the importance of starting good operational troubleshooting practices and having excellent tools like Loom early in the system, instead of trying to backtrack from the right to the left.
Amazing. And do you find, from your experience, do you find some companies trying to skip several parts here and skip from the infrastructure as a service direct to a service-led architecture without evolving gradually over time?
Yes, I do find that, and I find people who they, especially in the platform as a service layer, they say, well, we don't want to have to deal with infrastructure. We want to go to an infrastructure provider that takes care of all of this for us. Or in the private cloud, they'll say, well, we just like to go to containers and a container management solution on bare metal. But as I always say to them, at some point, you have to manage the infrastructure, whether it's managing the infrastructure from a bare metal standpoint, and again, that's infrastructure as a service, then you're going to have something that coordinates that. If you're using it in the OpenStack space, you're going to have the project called Ironic that manages your bare metal. But even if you use something like a public provider, what the public provider does is it's not so much it manages it for you, but it pushes the onus and the responsibility onto the user to put more HA and more operational processes into making the application more resilient. So if you don't manage your own infrastructure, it's not the infrastructure provider that that really cares so much about you. What they're saying is, we'll take care of it to an SLA that we can provide, but in reality, the onus is put on the customer and put on the application owner to make sure that there's no failures, no degradation of service. And again, it's going to be based on capacity, load balancing, and horizontal scaling versus the traditional vertical scaling.
Mm-hmm. Well, I couldn't agree more. We actually see the same trends in the market. But let's drill down on this. Let's focus on so this webinar is about OpenStack and its monitoring challenges. Let's focus on this section and talk about the challenges that we hear from the market. These are the main problems that we hear from our customers today in the context of OpenStack monitoring challenges. First, they feel reactive. So when your monitoring approach is based on thresholds and metrics, it usually means that you detect issues after they happen or when it's almost too late. The second point is that whether they use Nagios or Zabbix or any other infrastructure monitoring tool, maintaining thresholds takes time and demands and ongoing effort. And to be honest, some of them don't know necessarily. Let me say, it's not that clear how and what to monitor, especially in a dynamic environment like OpenStack. The third point is that since there's so many components in OpenStack, each emits several different log lines, performing root cause analysis is becoming harder than ever. And in order to find a single point of failure, users are trying to correlate events by themselves by using thread ID or tenant ID or other correlators that should give them a better understanding of what's going on, what's the underlying cause. The fourth point is, and the fifth is actually interesting. What we're trying to say here is that we all use metrics monitoring and happy about it, but many times they just tell you part of the story. I like to think of them as the metrics as the fever meter that tells you have a fever, but if you really want to know what to do about it, you probably go to the doctor who will listen to your full story and diagnose that you have a flu. So if metrics are the fever meter, then logs will be the full story. And you need to monitor these on an ongoing basis. The problem, on the other hand, with logs is that they need to be translated to plain English if you want to get actionable intelligence out of those. And this is a very labor-intensive job. So that's the fourth point. And last, I mean, the skill gap issue is very common. Many of our customers complain they struggle to deploy OpenStack environment. They lack the knowledge required for properly maintaining it. So I'd go back to you, Dan. Would you agree with the above? Could you share with us some real-life examples of common problems that your customers are experiencing in the context of OpenStack monitoring?
Absolutely. This is a common theme. These are common themes that we see over and over again. I deal with most of the large service providers in the United States, and we see this when we convert some of their business units from traditional architectures into cloud. We take their traditional ways of monitoring and their old legacy platforms that have worked great on bare metal. They may have even worked great in a virtualization platform like VMware, but they just don't work anymore for monitoring the infrastructure like OpenStack. Now, OpenStack, like all the other cloud platforms, they're very distributed. They work off of REST APIs, and they're basically microservices that talk to each other through a lightweight messaging layer, usually something like RabbitMQ, or earlier on it was Cupid, and could be ZeroMQ in the future, and they're back-ended by a database. People say, well, okay, you have a whole bunch of APIs and then a messaging queue and a database. How hard could that be to monitor? Well, it's not so much monitoring the individual components. It's actually monitoring the messaging and monitoring the trans communication between the services and following the requests. Now, we have we have companies that were following the old model and being reactive and just diving into log files. But what they find there is the correlation between the log files. Once the request comes through, they have to chase that by hand. They have to look at what the error messages were, which may lead them to additional log files in the messaging queue or in the database. And it becomes really more of a Pink Panther situation or a Clouseau, where you need to go and be a really, really good detective. In order to do that, you talk about skills gap. We have folks that have come out of a traditional or legacy environment that are just learning these tools. They're just learning OpenStack. They're not operators of large clouds, or they don't have years and years of experience because it is such a new platform. And the actual reaction time to the incident and return to operation gets extended from when they are running legacy platforms, because they are trying to learn and trying to catch up. OpenStack's a non-monolithic and decoupled platform. It's got a ton of advantages because of that, but it's just not simply one platform. And we find that companies have problems going from virtualization to OpenStack in the operations realm because of these issues and the correlation and tying it together. And even then, when they tie it all together, they still don't have a solution on how to fix it. They may not understand the underlying infrastructure components. As I said, with the service providers I work with, and even when I built American Express's first cloud, I led the operations team. And it took me quite a long time to train them up on how to read the log files, how to read the errors, how to understand what the errors meant. But then as part of the job, they had to figure out how to correct them. So it was a long time until we figured out how to really maintain and run OpenStack.
Right. So it's not just the logs. You need the logs to be actionable, of course.
Absolutely, absolutely, and and the human factor is a large part of this. There's so many. When you have so many different moving parts underneath that, and so many APIs that do so many things, the amount of simulated scenarios only tends to come when there's a problem. As the cloud grows and more of the APIs are exercised, more of the features are used, those scenarios become exponentially larger. So you can't even have back in the old days when I used to do tech support for internet providers, we used to have a virtual notebook. I mean, I even had a paper notebook that I would write down and say, well, when we see this error, do this. When we see this error, do that. Literally, if you had to write that notebook for OpenStack, because of the actual how many APIs there are and how many different services are running, I would estimate that the notebooks would have to go from the floor to the ceiling. It's really the scenarios are that numerous. So that's the things we see with some of our new OpenStack customers, where they need to build up that experience quickly, or they need a tool that'll help them jump the gap and maintain the business advantage that they get from running an agile platform like OpenStack. Absolutely.
Thanks for that. Great. Okay, so we'd like to ask you some questions, guys. It's time for a poll. I want to ask you, how does your organization deal with OpenStack monitoring challenges? And you should see that poll coming right now to your screen. I'm going to share the results with you guys. Let's wait a few more seconds. And let's hold on. People still reading. That's good. All right. The poll is now closed. Let me share my screen with you. Do you see it now, the results? All right. So most of the organization here deal with OpenStack challenges by using ad hoc solutions, whether they're doing some manual searches or they're using multiple solutions for doing that. And I have to say that I'm quite surprised in a good way that 21% of you guys are looking for a sustainable solution, which is great. You came to the right place, and I'm going to show you this a potential solution for your problem to this specific webinar. So stay tuned, and thanks for sharing your answers with us, guys. All right. So coming up, I want to share with you some AI development in the world, and I want to ask you, or let's ask together, how can we harness AI for our daily monitoring challenges? And let's start with the high-level view of the real-life applications of AI in the world today, and then focusing on the IT operations side of AI. So here are some real-life examples of AI. We'll start with healthcare. I like that because there are quite a few AI uses for that. A very interesting example would be Watson by IBM, where they analyzing disease by making information available for physicians who only have to go through their personalized reports instead of reading through dozens of papers for every patient's case. The second example would be from the stock market, where AI algorithms are used for identifying stock behaviors and loss prediction by purchasing particular stocks. And these are all based on metadata analysis. By the way, just for FYI, we'll be running a more in-depth webinar with our CTO to go behind the scenes and discuss unsupervised learning techniques. So feel free to follow us for some more details in the future webinars. The third example would be the computer vision, where I'm sure you all heard about image classification, like Microsoft Xbox, or for body part identification and creating semantic maps. The last use case can be banking, where the basic stuff is fraud detection, of course, but some are focused on detecting the loyal customers based on their activities. So these are general applications, right, of AI. Now let's look on applications in the IT operations domain, because this is what we came here. So here are things that I'm really more aware of because we're doing most of the things that's reading here. So AI solutions can be harnessed to the benefit of IT and to enhance overall performance. And let me talk about several examples. First, adaptive thresholds. So maintaining the alerting rule engine is a continuous and repetitive work, and the methodology is very straightforward, right? So you should act on false alarms and make detections. But for humans, this means fast burnouts. But for machine learning, this is a classical problem to solve. Second example would be prioritizing alerts, right? So quickly getting to dozens of alerts with the same severity is almost inevitable when you manually maintain the alerting rules. However, it makes so much sense to prioritize those based on features such as past behavior, magnitude of the current alert, or how many other alerts and from which source are concurrently triggered. Obviously, human can't do this, but again, for machine learning, this is a common use case. The third will be root cause analysis. So when something breaks, typically lots of alerts will be fired. Determining correlation or even causality between the different alerts can help not only in grouping together related issues, but also in telling apart root cause from symptoms. So this improves the overall time to resolution, basically, or MTTR. And to determine that two alerts are related, or even that one is the cause for the other, you can use machine learning techniques such as clustering, which we're going to talk about it later on. The last example that we started talking about is the real-time insight. So real-time insight is about applying recommendation algorithms to your ticketing systems, right? We all want to be able to maintain a knowledge base of issues and fixes, but this is hard because you expect the human to look at the current situation, then come up with a good query that will have the KB return the relevant past incident. In fact, we've already grown accustomed to experiencing machine learning in support side. So we get recommendations for similar questions, we start typing our own. So machine learning can do magic by recommending the relevant resolution. And you're going to see it in action in a second. So if we could generalize this, so as of today, humans are better at top-down, or I would say open-ended questions, but they don't scale, right? Machines, on the other hand, are superior in pattern recognition and following a strict methodology, and in places where there is large dimensionality, but really bad at open-ended questions or questions that require intuition. So we at Loom wanted to build a software that take advantage of both worlds. So we came up with the idea of unified cloud monitoring. Unified Cloud Monitoring is our AI team member. It has 4 key capabilities. First, collection. So collecting the data and parsing it automatically without having you to define the parser, without having you to spend time in making sure the data is shipping successfully. The second capability is proactive detection of issues, right? So learning the baselines of your data to detect issues proactively without having you to define thresholds or configurations and make you sweat for getting the basic monitoring stuff that you're getting today with your tool. But when you use anomaly detection, you'll also be able to detect things that are about to happen or things that you're not aware of, as you're going to see in the examples. The third capability is the correlation and tracing. So as you said, and as Ben mentioned, correlating the incident with other incidents and tracing the root cause is the key for any distributed architecture, specifically OpenStack and its different components. And last but not least, the insight and recommendation. So translating the problematic log lines into plain English is something that we all need to hope for, because it's so hard to do it yourself, and trying to Google for the answers is very labor intensive. So each one of these capabilities utilizes different machine learning algorithms or deep learning in some aspects. But as a whole, if you use that as a solution, it allows you to achieve what we call operational excellence in your IT. So what I like to do now is I like to share with you some live demonstration of our solution. But before that, let's do another poll. And I want to ask you, in the time of the event, do you use logs for troubleshooting OpenStack issues? So you should see that poll coming now. Very basic question in this case. Few more seconds. All right, so let's close the poll. Share the results with you guys. So, 73% of you said that they use logs. That's great news. I mean, we don't take it for granted. And only a few of you use logs. Well, probably a lot of infrastructure team members here, because when you say logs are being used by the application team, that's something we see a lot. We see that infrastructure teams usually use the metrics for the infrastructure, and logs are used by the dev themselves, or the level 3 support, level 4 support. But this is something that we think can be majorly improved, and we're going to show you how we can extract insight, even infrastructure-related insight, from the logs. And the rest of you that use logs, that's great. Let me show you how we can help you speed up things, and how we can find issues for you and help you to become proactive about your business with our solution. Ben, do you have any comment? Sorry, before Ben, you continue. Ben, do you have any commentary on this? You said you used to use logs a lot.
Yeah, I used to use them a lot when I was, when I was an engineer, an infrastructure engineer, again, for American Express, or when we used to use it in Mirantis for deployment. And the problem with the logs, if you're using them by hand and not having something help you do correlation or causation, is, and I trust me, I love the developers of OpenStack, but they're not the most verbose people when it comes to the Python errors, or the errors with the orchestration platform. So when you use your logs, and you, for example, you talk about the persistent storage project called Cinder, and you look in there, and it cannot provision a volume for your new instance. It doesn't say that. It doesn't say, "Hey Ben, sorry, couldn't get that done because the backend storage isn't ready for me. So please feel free to go ahead and look at the the storage console and make sure that volume has been carved out." No, it doesn't say anything like that. It gives you a cryptic message like, no resource available not able to complete tasks.
Mm-hmm.
So, that's completely useless, right? Because we don't know what resource. But if you take the different log files, and now from Cinder API, you go to the Cinder volume log file, it give you a little bit more, and you go to the actual log file from the storage, either Ceph or from the application or the appliance, and you get a little bit more information. This all takes time. This all is delaying the solution, and sometimes, as we said, with the skills gap, people don't know where their next step is, what the next log file is that they need to look at. Again, a major time suck, which will then prolong the RCA, which will prolong the solution. So that is a persistent problem with those who just use logs. And your legacy platforms like Nagios, Zabbix, Xenos, you name it, BMC, they won't pick up these errors. All they know is the storage appliance is running fine. You can get to the storage appliance. The compute node is running fine. The control plane servers are running fine. But it's the actual specific information about the platform that takes a lot of fine-tuning if you're doing it by hand. And I see that you're using ad hoc solutions, a lot of you. And you're probably taking some of these legacy platforms and running them through a self-built processor and doing some things with Elk. But again, multiple tools, multiple layers of abstraction if you're in your operations and in your troubleshooting and in your logging, monitoring, alerting. Now you not only have to watch your IaaS infrastructure, but your logging, monitoring, and alerting infrastructure is now very complex. So you have dozens of tools to monitor a very dynamic and disaggregated platform. That is a lot of moving parts. In OpenStack in general, simplicity and automation are your friends. If you don't take anything else away from what I've said today, just remember this: with OpenStack, simplicity and automation is the way.
I like that. Well, thanks for sharing it. I think you touch exactly the point of how hard it is to find the answers when first you have the blind spot problem. You don't see everything, and then you have problems understanding or deciphering what exactly needs to be done when something is misbehaving. So these are exactly the two challenges that we hear a lot. And let's see it in action. I mean, we talked about what can we expect from AI, but let's move to a live demo of our solution, and then we'll wrap up everything and leave some time for Q&A. So guys, with that, I'd like to share with you Loom user interface. Welcome aboard. That's the unified dashboard screen. So this is the screen you get out of the box when you deploy the software. Loom can be deployed on-prem or SaaS, depends on your needs. And once you ship the data into the software, as I'm going to show you in a second, you get this dashboard will give you an overview of your health score based on how many incidents you have in real time. And you can see all your incidents grouped by their application here in this feed. You can see some big numbers about how many open incidents you have currently, how many logs were analyzed, and what's the mean time to resolution you currently have. And if you improve it over time, you'll see that number changing and the trend that you're having. So some data volume metrics, and of course it's clickable, and the error rate that you're having currently in your data. Of course, everything here is interactive, and you can click on each one of those to see the exact incident, as I'm going to show you in a second. But before that, I'd like to say a few words about everything, where everything starts. So when you deploy our solution, whether it's on-prem or SaaS, everything starts by connecting your new data input. So the software comes packed with different plugins or collectors, as we call them. You can ship data from Linux server, Windows server, OpenStack components, of course, and many different input methods. And it's a wizard-based approach of guiding through the process of streaming the data. We can use RSysLog, we can use Elastic configuration, because most of you probably using ELK today. And also we can provide you with our own agent that does automate everything for your collection phase. So collection and shipping is where everything starts, and it's very easy to skip that phase. After data was shipped successfully to the software, the magic starts to happen, and I want to share with you what Loom is, how we use AI for structuring your data automatically. So here's the scheme. Here's the automated scheme that will come up from Loom. Here I have an example of Keystone logs that I'm sending into the software. That's the raw input. I'm highlighting now in blue. That's the raw input that Loom receives from Keystone. And you can see on the left side, what we refer to as auto discovery results, you can see how Loom is able to break it into lists of key and value pairs. And also, and also to classify each one of these fields accordingly. So it figures out that's the message, that's the severity, that's a host here, and that's a timestamp, and the rest are just properties that should be analyzed, but for different reasons, to give you the context. Now, for the more advanced users that you have here, if you want to add your own manipulations of your data, I don't know, add your own JavaScript code to do some extracting different metrics or do some time shifting, you can add your own JavaScript here. You can see immediate results or choose from a list of templates that we already support. So, but that's just the first phase of helping you get the right data in place and help you structure it so you don't have to do it yourself, because we know it's a pain. Log sessions are a pain, and other solutions are a pain. And we think that you don't have to waste your time here. You should focus on the actual analysis phase. So let's talk about that. Let's go to the incident screen. That's our main system screen. And let me give you just a brief overview. On the left side, you have the feed of events. That's your inbox, okay? These are events that were generated automatically by our software. So these would be anomalies, basically. You can see the details of the event in the middle. And we're going to talk about it in a second. Action buttons and machine learning buttons in the top right side, and insight on the right area. Now let's start with a first example, more of a complex example, but I think I like it. It's a correlation between two different issues, one from the Nova and one from the LibVir. And we can see here an example of three different incidents. These incidents are anomalies, right? So you have your Nova compute log has many errors on the one hand, and on the same time, the QEMU has this log line appearing more than usual, failed to allocate whatever, cannot allocate memory. And another message coming from the Nova compute log, the same LibVir error, unable to monitor, connection listed by peer. So you have these three messages, but Lou is able to tell you that, you know what, guys, all of this is part of the same incident. These alerts should be consumed as one incident to give you the context you need to perform root cause analysis. And the way we do this is by using these. First of all, the events are correlated based on their time. They all occurred more or less at the same time, but they also share the same metadata. For instance, they all came from the same host here. And you can see that what Loom is doing is actually it uses entity extraction from the log lines to find what are the interesting fields that you have in your data, and then try to ask what else went down, what else changed, and what else is anomalous that share the same metadata, as if it was a human being. So we've been observing different types of DevOps engineers in the way they work, or cloud ops, and we've seen that they have conventions in the way they perform the actual analysis. And these conventions include looking for, I don't know, I have an anomaly in this IP address, so I'm taking this IP address and going to search for this in my Splunk or whatever. So Loom actually does that. It finds interesting anomalies, it finds interesting fields within these anomalies, and then correlate them with other components all across your stack, whether it's only OpenStack or if you're talking about the applications, whether it's running on top of Docker or Kubernetes or whatever, we can correlate everything in one place. So you don't have to spend time performing the root cause. The root cause will probably appear in front of you. Now, if that's not enough, and as we spoke before about the problem with understanding logs, if you look on the right side, you can see Lucy. She's our AI team member, and she speaks to you and explaining in plain English. If you see that error and your instances go straight to error state, it means that QEMU failed to launch the instance, probably due to insufficient memory. And there is a recommendation, of course. It tells you that many unused zombie VMs on one hand, or your Nova menu configuration is not sufficient to fulfill the requirement. So these insights are based, or this is what we call a TRICB, stands for Tribal Knowledge Base. And this is a knowledge base that is keeping updated on a daily basis from our data scientist team, but also from all of our customers. So if you as a customer add your own insight and help us understand what exactly did you do in order to resolve that by clicking on the green button here, Loom will learn from your experience and save it in your organization for future reference. And if you choose to share it with the community, then these insights will be shared with all the rest of our customers as kind of like a crowd wisdom model. So that's a great way for documenting the knowledge internally and saving the work of trying to figure out for the resolution yourself in the internet. So, okay, so we talked about this correlation, but I want to show you a different kind of example. Let's take glance, for instance, right? So here we have a different type of anomaly. We can see here 2 anomalies from the glance API log. And this is a new type of anomaly. We call it new behavior. New behavior is actually, it's the first time that our software detected this type of pattern in your log. So it's the first time that this message appears. And this is very interesting because sometimes it will help you it will help you to detect issues before they affect your business, because it's the first time that this pattern appears in your data. And we can see they all came from the same tenant AD, which is a very good correlator to use. And you can see again, there's insight and resolution explaining to you that it was part of the Keystone is not configured as Nova's authentication strategy. And here's what you have to do in order to resolve that. But what I want to share with you now is that if you want to drill down deeper, if you want to do some slicing and dicing yourself, you can click on the search logs icon here, which will redirect you to our analytics screen, which is the second screen of Loom, where you can see your logs spread over time. Here it's built on the Elastic capabilities, and our solution comes back with Elastic, so you don't have to define your own Elastic or Elk bundle. Loom comes back with an enterprise-grade Elk. And we show you exactly the raw log lines, and then you can slice and dice and focus on specific time frames, maybe add some queries here with AND and OR operators. All the basic capabilities of slicing and dicing are already existing in the solution. And the cool thing is that when you go to the analytics, Loom takes you filter already the results based on their time and the relevant service. So you don't have to waste time on doing some bottom-up analysis, but you can use the incident feeds, which are generated automatically, and only when you find something interesting, if you want to drill down deeper, click on the search logs, go to the raw data, and continue the searches from that point over. So it makes your work, your life actually much more easier, because you know about things proactively, and you're able to drill down deeper if you're interested. If you don't want to drill down deeper, that's fine. The insights are more than enough, and you should be able to know exactly what needs to be done in order to resolve that issue. We're quite short on time, so I want to just show you 2 more things and just maybe have some time for Q&A. So of course, you don't have to use Loom as a user interface. If you're interested in looking on alerts and other screens, we support a lot of different integrations for the notification part. So you can use, you can get these alerts in email. You can use Slack or webhook or a generic webhook or HipChat, PagerDuty, whatever you want to use. You're going to probably find yourself as part of the integrations. We're always open for new suggestions. If you have other integrations you want us to have, by all means, shoot us an email. We'll be more than happy to add this to the integration section. And of course, if you have your own custom alert that you want to add, everything you see now was actually anomalies, right? So we use statistics to detect these issues before they affect your business. But if you want to add your own custom alert, there's a section here where you can define your own rules, and so you feel more control. So many of our customers came to us and say, all right, guys, everything is automated. I like that. I like the AI part, but I've been nurturing long lists of alerts for years now, and I want you to support that as well. And we now do offer that kind of custom alerts, and you can create your own manual thresholds and make sure that Loom got you covered, both from the AI perspective, but also from the traditional monitoring perspective. So with that in mind, I'd like to go back to the deck that I have here, and to wrap up what you've just seen with our solution. So these are the benefits that you're going to gain when using Lucy. First, you will be able to gain real-time visibility centrally across compute, network, storage, identity, telemetry, and other components of your OpenStack deployment. Second, you will be able to correlate events, which is so important, across different OpenStack components to trace the exact root cause of the detected issues. And last, you will be able to get recommendations and action items for the detected issues from the proprietary crowdsourced knowledge base, which we call TrickBee. So that, in a whole, is this solution from the parsing to the automated detection issues and enrichment should allow you to get become proactive about your customer's problem and also dramatically improve the mean time to resolution, but almost twice as fast as you do today. All right, so I'd like to thank you so much for listening up until now, and we encourage you to take us for a ride. If you're interested in a free trial, just drop us a note and we'll take it from there. I'd like to thank you so much, Ben, for being with us today, and please stay up for the Q&A section, and so we have some time for you guys to ask your questions. We collected all these questions by now, so let me open them one by one, and if you have some comments, Ben, in the meantime, that will be a great time.
Great, I'm ready.
All right, super. So we have a question from Jamie asking us, can our solution analyze logs from other applications, not just OpenStack? All right, great. So I think it's a great question. As you've seen before in the demo itself, what we do is that we have collectors for different types of sources, whether it's OpenStack components or web servers or the actual application. So you can stream logs from the different layers of your stack and correlate everything in one place. So your infrastructure team can get notified about OpenStack issues, and the application tiers, whether it's the developers or the level 2, level 3 support, can get also proactive alerts based on their proprietary logs. Ben, what would you say from your experience? Is this something that for your customers usually use? They have different log management solutions for OpenStack and for the proprietary application, or they use the basic ELK stack for everything?
Well, I think the application monitoring, what happens is when companies migrate their workloads from legacy infrastructures over to the cloud, I think a lot of times the legacy monitoring platforms for the applications come along with it. Unfortunately, some of those legacy platforms don't have the best solutions or don't have any solution to monitor the infrastructure platform. So what we see is new ELK stack deployments popping up to monitor the infrastructure while they use something like BMC Patrol or some of the old legacy platforms to continue monitoring their applications. Of course, as you can just see by looking at that solution, there's no correlation there. So we'll get operations teams that get application errors that they'll drill down and say, oh, looks like it's an infrastructure problem. They'll throw it over to the fence, to the infrastructure operations team. That team will then have to dig through the logs, find out. Meanwhile, that the problem still persists and the RCA is still not found. So yes, so we see a lot of that. And as I said earlier, simplicity and automation are the key to success with cloud platforms, especially like OpenStack. And a platform or a setup like that is just not ideal.
I agree with that. Can you still hear me, guys? Because I have some noise in the background. Ben, can you hear me?
I can hear you. Yes, I can.
Okay, cool. So moving to the next question, I have a question about how can end user provide feedback on pattern-related baselines? So some kind of pattern is new, but a normal behavior should be flagged as anomaly. So let me address this and explain maybe how we do this, the anomaly detection on patterns. So we use what we call adaptive time window. Loom keeps on listening to the way your data behaves over time. And when a signal changes, continuously monitor the change as well. So the more data it gets, the better the baselines are tuned to it. So over time, after a few hours of work, after the first few hours of work, you'll start seeing meaningful anomalies from the last few hours. But after the first week or two, Loom will also be able to compare between Monday to Monday and Tuesday to Tuesday, because these are different times of the day. Now, the cool thing is that machine learning alone is not enough. You also have to listen for the customer's feedback. So if a user wants to tune the algorithm, he can there's several feedback loops. So you can press the mute or the raise button, which will tell the system that either you're not interested in getting these specific alerts because what's written in the logs is not interesting. The other type of feedback is about raising the thresholds in an automated manner. So we have a button we call raise, which stands for, it's actually a bit less sensitive. It tells the software that you're only interested in getting these anomalies only if their volume is much higher. So that's kind of that's kind of a human-based feedback that really really important for the solution to get. So it's always a fine balance between alert fatigue and not knowing about issues. So we use machine learning for the detection phase, and we use automated suppression for suppressing the noise, but we also use user feedback to tune the algorithms. And that's a very important note, and thanks for asking this. Maybe one more question. I think we have some more time. I have Srini ask us if we offer a free trial. So yes, of course, maybe I forgot to say it. Loom offers a free trial for 2 weeks of time. And we guide you with a customer success representative to take you through the process of seeing the data, connecting it, and actually see the results. And maybe one more question here. Okay, I have Will asking me how long does it take me before you get the first incidents? So, okay, that's a great question. Again, it depends on your volume of data. Loom starts to detect anomalies after the first 2 hours, because then it can be able to compare last hour to the previous hour. But after a week of work, it will also be able to compare 8 a.m. Monday to 8 a.m. Mondays. And if you have historical data, what you can do is you can ship a dump of data of a week, let's say a week of logs, and then Loom will learn all of this in real time. So after the first few minutes of waiting, you will be able to work from that moment onward with a real-time automated detection mechanism. And I know we're almost at the top of the hour. So I think that's a good time for saying thank you so much for attending here. And thank you so much, Ben, for your participation. That was an insightful talk.
Thank you, Dror. I appreciate it. And I want to thank everyone for attending as well. I had a great time. And if anybody has any additional questions, feel free to connect with me on LinkedIn or through Twitter.
Thanks again, Ben, and thanks everyone. Please stay tuned. We're going to have a list of two additional webinars this month. So we're going to share with you the results after that. One will be on around unsupervised learning techniques and machine learning, and the other one will be announced soon. So thanks again. Thanks, everyone, and thank you, Ben. Bye-bye.